Hi, welcome to Nomis Academy. In this video, I'll be teaching you Pythagoras with simplification. Pythagoras with simplification. So let's get into what we have for this video. Now let's take some example to solve Pythagoras with simplification. When we talk about Pythagoras, we're talking about right angle triangle, having one side to be hypotenuse, the other side to be adjacent, and the last side to be opposite. So what happens to simplification with it? So let's take an example. Example number 1. The question says solve for x in, so there is a right angle triangle of this. So here we have x plus 3, and here we have 8, and here we have x minus 1, and we have to find the value of x for this. So when we look at it and we remember Pythagoras, we should be able to remember Pythagoras theorem. Pythagoras theorem that says that the square of the hypotenuse is equivalent or is equal to the sum of the square of the adjacent and the square of the opposites. So when we remember this, we think about what we have on the screen. We have the hypotenuse to be carrying x plus 3, we have the opposite to be 8, and we have the adjacent to be x minus 1. So we are going to take the Pythagoras theorem into simplifying this triangle that we have here. Therefore, we say recall that hypotenuse squared is equal to adjacent squared plus opposite squared. So what do we have as our hypotenuse here? X plus 3 all squared equals to adjacent is x minus 1 all squared plus our opposite is 8 squared. So this becomes x plus 3 multiplied by x plus 3 equal to x minus 1 multiplied by x minus 1 plus 64. So let us begin to open the ones in the bracket. X multiplied by x, we have x squared. X multiplied by 3, we have plus 3x. 3 multiplied by x, we have plus 3x. And then 3 multiplied by 3, we have plus 9. Equals to the same thing should be done here. X multiplied by x, we have x squared. X multiplied by minus 1, we have minus x. Minus 1 multiplied by x, we still have minus x. Minus 1 multiplied by minus 1, we have plus 1. And then lastly, plus 64. So what do we do next is to take like terms or collect like terms. So how do I collect like terms? Let me start from that of degree 2. I'll say x squared. Do I have any other x squared? Okay, these are the other side. Then it comes to this side, becomes minus. Remember that it's having a positive sign here. So if it's having a positive sign, then you have to bring it here to become minus x squared. So let's continue to pick like terms. We don't have other x squared, so let's take number with x, right? So we have plus 3x plus 3x plus 3x. Then this is minus x. No, this is equal to minus 1x, right? So when you just see a letter written, that means it is one of that letter that exists. So this is minus x. When you come to this side, become plus x. Then this minus x. When you come to the other side, become plus x. Then do we have any other x? No. Then let's take the number to be at the other side. So we have 1 plus 64. Then this is plus 9. When it's close to the other side, it becomes minus 9. So x squared minus x squared is 0. so we have nothing left there. 3x plus 3x, that's 6x. 6x plus 1x, 7x. 7x plus another 1x, that's 8x. So here we have 8x equals to 1 plus 64 is 65, and 65 minus 9 is 56, right? 65 minus 9 is equal to 56. So we divide both sides by 8. 8 cancel 8. Then 56 divided by 8, what do you think? 7, correct. 8 here 1, 8 here 7. 7 over 1 is equal to 7. Then we can tell that the value of x is equal to 7. You can see how we simplify this Pythagoras theorem here. So let's take another example, example number 2. Example number 2. So we have to simplify the same thing. So we have a triangle of this, and we have 2x plus 7, and here we have 2x minus 1, and here we have 12. So when you look at it, what is our hypotenuse? 2x plus 7. So